All right, we have the MathCounts homework for the 16th of September. The main thing that we learned today is what happens when you divide fractions with a 9 in the denominator, in the bottom of the fraction. So in general, we can say this. Whenever you have 5 divided by 9, this is going to be 0.555555, or just 5 repeating. That's the general pattern. We looked today, we said, okay, 1/9 is 0.1 repeating, 2/9 is 0.2 repeating, 3/9, so I'm gonna give myself some room because you'll see what's gonna happen in a sec, is 0.3 repeating, etc. The pattern is when I have one single 9 on the bottom, you repeat the top number over and over again. Remember that 3/9 can be reduced, right? I can divide the top and the bottom by 3. 3 divided by 3 is 1. 9 divided by 3 is 3. So this is really the fraction 1/3, which is the rationale behind why 1/3 is this repeating decimal of 0.3 over and over again. So 5/9 is just my quick recall of, do you know the general pattern? And then there's another pattern that we saw. When you have a bunch of 9s at the bottom, the number of 9s on the bottom dictates how many times this will repeat. Because I have 2 9s at the bottom, 4 and 7 will both repeat, and this is going to be 0.474747, and the 4 and 7 repeat. Our shorthand for that is having this lenticulum, I think that's what it's called, above the 4 and the 7 to indicate that this is 474747, on and on into infinity. All right, let's try another one. So in this case, because I have 2 9s, these two numbers are repeated. And you might be thinking, Mr. Snell, there are not 2 numbers here. Well, that's because there's a hidden 0. Here's what a lot of students will think on this problem. A lot of students will say, yeah, well, this is 0.7 repeating, and they will be wrong because there are 2 9s. There needs to be 2 numbers that are repeated. If there are not 2 numbers, you need to make your own 2 numbers. The 2 numbers are really 0, 7. That's the reason that we have a 0.07, 07, 07, and it's 07 that gets repeated, not just the 7. All right, sometimes you need to build the 9s on the bottom. In general, in math, you usually have a number that you want to either divide by 1 with a bunch of zeros in the bottom, or divide by fraction with a bunch of 9s on the bottom. Those are the 2 most common types of fractions that you'll see with decimals. If you can build those, you're in good shape. So in this case, I know that the 11 is going to probably turn into some 9s because I'm repeating the same number. Repeating the same number is the 9 trick, right? So I can multiply this fraction. I can multiply the bottom here by 9, and then the bottom will be 99, which is the similar type of problem that we just had to number 3, right? Number 3 and number 2 were both divided by 99. That's the one that I wanted. I wanted to divide by 99, but I can't just willy-nilly multiply the bottom by 9. If I multiply the bottom by 9, I also therefore must multiply the top, the numerator, by 9 as well. Therefore, the top 2 times 9 is 18. And the number that I'm really repeating over and over is 18 over again. This is 0.181818. This goes on forever and ever and ever. And we just put that line above the 18. So you can build your own 99. All right, let's check with number 5. Number 5, very similar. We want to have a bottom that is either 1 with a bunch of zeros, which it's possible on this one, but it's way easier to turn this one into just a 9. If I can somehow get a 9 in the denominator, in the bottom, then I'm in good shape. I can just repeat whatever that number is over and over again. So the question is, 3 times what number here gives us 9? Well, 3 times 3, Mr. Sandell, gives you 9. And again, if you multiply the bottom by 3, you also therefore must multiply the top by 3, and 2 times 3 is 6. Therefore, I'm going to be repeating 6 over and over and over again. This is 0.6 repeating. All right, let's try number 6. Oh boy. So the first thing I'm seeing is that there's kind of 2 trick questions here. There's 3 numbers down here. There should be 3 numbers up here, which means there's a hidden 0. Let's go ahead and write in that 0 right now so I don't forget about that. And the next thing that I'm seeing is this is not 9s. You have to have 9s. You can't just have 3s. 9s is the trick. You have one of 2 options, right? You have to have either a bunch of 9s in the bottom or 1 followed by a bunch of zeros. This is a case where the whole thing is a case where we have a bunch of 9s in the denominator. So I'm going to multiply the bottom by 9. No, I don't want to do that. That won't work. Multiply the bottom by 3 because 3 times 333 is 999. 3 times 3 is just 9, right? And I'm kind of distributing 3 into each of those. So I can say that the bottom now is a bunch of 999s. If I multiply the bottom by 3, I therefore need to multiply the top by 3 as well. And this is a little bit harder for students to do, especially to do it in your heads. Again, the way that I think about this in my head is I do 3 times 8 and I get 24. Write down the 4. The 24, I'm holding the 2 in my head, but I can write it down if you would want. And then I do the 3 times 1, which is 3. I add the 2 that are usually on my fingers, and I get 5. So the answer here is going to be 54. But remember, if there's 3 9s in the bottom, there have to be 3 numbers in the top. Therefore, that hidden number here is again a 0. Therefore, our decimal is going to be 0.054054. That 054 repeats over and over and over again. All right, we're almost there. Number 7, again, kind of the same thing. We have a bunch of repeated numbers down here. Therefore, if we multiply the bottom by 9, we will actually have a bunch of 999s in the denominator. If I multiply the bottom by 9, we therefore must multiply the top by 9. And there's not really a nice way to do this other than kind of save the 0 for dessert. So I'm going to ignore the 0 for just a second. Let's do 9 times 6. I get 54, so I'm going to write down the 4. I'm holding 5 fingers, but if you want, I write down the 5. Usually, I store my digits to carry on my fingers, and then I do my 9 times the 5, which is 45. And 9 times 5 is 45, plus 5 is 60, and I can erase my fingers. I can say it's now 60. So I get 60 and 4, so 604. And then remember, we saved our 0 for dessert, so the 0 is going to come back over here as well. And this is the way that most students will solve it. It's still kind of tricky because it gets yucky, and then you realize really quickly there must be a better way. I'm just going to go ahead and abandon ship right here. There is a better way. This is a little bit too slow. Here's the way that you do want to solve this. Simplify this fraction first. Make things as simple as possible. So watch what I can do. I can say that if I can have a 5, 5, 5 over 1, 1, 1, I know that when I do the division, this entire thing is going to turn into 5. Because I can divide the top by 111 to get the 5, divide the bottom by 111 to get rid of everything, and therefore the answer is just 5. If I have 555 divided by 11, that's really, really close to 560. This is one of the last tricks that I showed in class, so if you're lost, that's okay. And again, if I have like denominators, I'm allowed to add the numerators. So what number plus 555, what number here do I add to 555 to get to 560? Well, the missing link here is 5. So really what I had here is this is the simplification that makes this problem much easier. And now I'm going to multiply by 9. So now I'm going to say times 9 times 9. The bottom here is still 999. The top is 5 times 9, which is just 45. And be careful. Again, 3 numbers in the bottom. You need 3 numbers in the top. So I'm going to put a 0 here. I know that my answer is going to be 5 plus whatever this decimal is. That decimal is 0.045 repeating. Therefore, my final answer is 5.045 repeating. Cool little trick there. All right. And then I couldn't think of a challenge example because I had like 30 seconds and people were screaming about swords. So I just gave another easy one. Again, you're trying to get to 9s in the bottom. So I'm going to multiply by 3. 3 times 3 is 9. And then I can say 3 times that 3 is also 9. Therefore, we get 99 in the denominator. From there, I have to multiply the numerator by 3 as well. Again, the way that I'm doing this is 3 times 5 is 15. So I'm holding a 1 up for the tens place. 1, 5. The 1 is on my fingers. Here, I'm showing you my fingers. And then I'm going to say 3 times 2 is 6, plus the 1 on my finger is 7. And I have 75. And again, you just repeat that over and over again. This is 0.75 over and over and over again. One quick thing that I really wish I would have done if I had more time. This is a secret number 9. If you're watching the video, please do this one as well. What is 9 divided by 9? And I'm hoping someone is going to say, well, you just repeat this one over and over again. That's 0.99999 repeating. Again, my handwriting is not ideal, but it's 0.999 repeating. There's an infinite number of 9s here, right? That goes on and on and on forever, never, never. But wait, isn't 9 divided by 9 1? And you're right, it is. It is equal to 1. Therefore, 1 and 0.9 repeating are actually the same number. It's something that a lot of budding mathematicians struggle to rationalize. In the same way that 1/2 and 0.5 are the same number, 1 is the same number as 0.9 repeating. It's the same exact thing. It's just different forms. And hopefully you're struggling with this the way that I am. My plan is tomorrow to go over a few different proofs of why 1 and 0.9 repeating are the same number. Thank you for watching, guys. I'll see you later.